I'm going to take the first equation, I'm going to multiply it by 5, and then I'm going to take the second equation and multiply that by 2 and add them together. So let's see here. We wind up with, first equation would be multiplied by 5, so I get negative 10x, negative 15y, and negative 30z. And then multiply that by 5 gives me a 2, is it 120? Oh yeah, 130, sorry. I was thinking of 2. Okay? Remember, you guys have a calculator. I'm just trying to use my brain. You all know how my brain works sometimes. Second one, I can multiply by 2. I could probably double these without getting into too much trouble. All right. Start simplifying things through. It leaves me with negative 5y, negative 22z, and that would be what? Negative 82. That's fine. Absolutely fine. All right. I'm going to do basically the same idea with eliminating the x value in the third equation. It's what's so big here. So I'll just move that over. Same idea. I'm going to take the first equation. I'm going to multiply it by 3. So we get negative 6x, negative 9y, negative 18z equals negative 78?
Yeah.
Thank you. Take that third equation, multiply it by 2. 6x, 8y, negative 10z, negative 80. Remember, when you have same coefficients, opposite signs, we always want to add them together. So we do that, we get 0, negative 1y, negative 28z, and then negative 158. I'm assuming you probably did everything by negative 1 again. Everybody see why I use multiplying everything through by negative 1? We don't want to be negative people. We want to be positive, upbeat people. Just shut up. What I would do now is I would just use direct substitution. I would say y is, forgot the z, excuse me. I'd say y is 158 minus the 28z and just use the substitution. Could you multiply by a scalar and subtract? Sure. But for me, for some reason, I like substitution. I don't know why. Distribute in, you get a 4, 9, so 0, 4, 25, 29, 790.
Yeah. Yeah.
0, 140. Negative 140 and a positive 22 is a negative 118. 790 over gives me a negative 708, I believe.
Yes.
Then from there, I 6. Z equals 6. So if that's 6, $28 times 6 would be, what is that?
86 times 6.
168. So subtract the numbers. So we have y is negative 10.
Yes.
And then lastly, so we have z is 6, y is negative 10. So 3x plus negative 40 minus 30. Do you get 10? Okay. It's just kind of messy with that one because there's a lot of scalars going on. You just got to be careful in how you multiply through to eliminate out. Okay. Were there any others you would like to peruse through? Yes, sir.
Can we go over?
Do you have $1?
Put it down my tab. Okay.
We talked about 31 first hour also. And in 31, I kind of did the same basic idea. I looked for one of them that has the alternating signs. And I see that the x value in the second equation is negative, but the x value is positive in the first and third. So I'm going to use that second equation to eliminate the x values in the first and third. Okay. So I know that I have to multiply the top equation then by 2, the middle equation by 7 to get rid of the x's. So if I double the top equation, I have 14x negative 20y 16z negative 100. Multiply the bottom one by the 7, negative 14x negative 35y 84z and negative 630 at the end. Add those 3 pieces or 4 pieces together. Don't forget to put your addition symbols in there so you remember that's what you're doing between each one of them. Somebody will forget. I have negative 55y. 16 and 84 is 100 z. And lastly, that's negative 730. Here's my first two variable part. All right. Do the same thing. I'm going to multiply the middle equation by 3, the bottom equation by 2, again to eliminate the values of x. If we do that, we get negative 6x minus 15y, 36z, and negative 270. Double the bottom equation, we have 6x, 8y, 8z, and a 52. Okay. X's are eliminated. I have negative 7y. 36 and 8 is 44. And negative 270 and 52 gives me negative 218. So now I'm here. What stinks about this one are the coefficients. They're just gross, like really gross. Yes, sir. Yeah, before you, I would eliminate y also, but before I do that, I'll make it a little bit easier on myself. What do all 3 of those guys have in common? 5. Take a scalar of the 5 out. If you take the scalar of the 5 out, it just becomes a little bit more manageable. Then you get negative 11. I mean, it's still not pretty, but 126. It's still the same equation, just with that scalar out. That way the numbers aren't as gross. They're still gross, but not like super gross. Yes, sir.
Why do you cross these
Because the z will look like a 2.
7? These are not supposed
You're a disgrace.
No, a lot of people, some people cross their sevens.
Yeah.
Yep. Yes, ma'am. Guys, what's up? Yeah, that's right. I have the negative 1.6. Is that not right? Thank you. Oh yeah, I carried a 1 over, not a 2. Thank you for checking that. Okay. So when I do this one, I'll multiply the top one by 11, the bottom one by 7, and it's just like you had earlier. It's just really gross numbers. So negative 77y. I don't know what 44 times 11 is, but it ends in a 4. 4, 8, 4. Negative 218 times 11 also ends in an 8. 2298. Okay. Multiply the second equation by 7s then. How much? 1022. Okay. And then we're gonna, excuse me, same coefficient, same sign, subtractions.
Wait, what did you multiply by 7?
Did I multiply by 11 by mistake? No, I did. Yeah, I did this one by 7. So this one goes away. 484 minus the 140 is 344. And then this would be a negative 6731. Is it 4? Six? Okay. 6, 4. I have to remember which one it was. The negative. Yeah, it has to be a 4. Negative 4, because 4 times 4 gives you 16. Yeah, the 6, I think 6 is with a different one.
The 6 is already.
Okay. Yeah, now you take that value, substitute in.
You get 6.
Okay.
You're welcome. Yeah.
1. So, along with these things, one of the ones that we just briefly talked about yesterday. Guys, come on. So what I want to do today is talk about how do we set these up a little bit more. Hey, yesterday there was a big mess of those all over the floor. So if I see that again, you're not going to get any of those. Okay? What I want to do here today is I want to walk you guys through, gentlemen, I'm talking. I want to walk you guys through how do we look at the difference between a system of equations word problem versus your linear programming word problems. Remember, your linear programming problems always had some objective. It said, you didn't have them. If you didn't grab that many of them, you wouldn't have messes of them on the floor. Remember, when you're dealing with linear programming will say, how many of something do you have to do in order to maximize profit? Versus these, how many do you need? How many of each type do you have? Things like that. All right, bless you. So what I'd like to do is kind of work with you guys to start with on the coin problem. On the front page, I think it's number 23, it talks about coins. The cashier has 25 coins consisting of nickels, dimes, and quarters. The value of $4.90. Number of dimes is one less than twice the number of nickels. How many coins of each type do they have? Well, as you get into this thing, you're talking about three things: nickels, dimes, and coins. So what I always do, just like we did before, define X, Y, and Z. You know, even though you have nickels, dimes, and quarters, you could use N, D, and Q, but I would steer clear of that because sometimes the letters just look awful, like A's, S for students, things like that. So this would be my nickels, dimes, and quarters. Just going right in order in which they talk about them in the problem itself. That's the best way to do this. Okay. Within the problem, then, it talks about two different things. It talks about the number of points you have, and then it talks about the value. So, how many total coins are there? 25 of them. So that means there's some combination of adding these three values up has to equal 25. It's relatively simple to come up with that. Next, you have to know how much each of these are worth. I know. A nickel is how much? 0.05. Dimes are 0.1. Quarters are 0.25. And you had $4.90, correct? Oh, yep, I forgot to put the variable. Yeah. Yes, sir.
I'm setting up. I just multiply everything by 100.
I was just about to do that.
Because I don't want.
No, you don't want decimals.
Like that.
Nope. Nope. So, right, I was just about to say that. Instead of dealing with those really crappy looking decimals, get rid of them. So you guys all know if you multiply by 100, you move the decimal place over twice, right?
Yeah.
That's the easiest thing to do. I would do that right away here. I'd move my decimal place over twice, and then I'm just going to rewrite this as 5x, 10y, 25z is 490. That way I don't look at this anymore. Okay? And now that I did that, there's one other trick thing I'm going to do right away. Take out the 5. Very good. I'm going to take out the 5. Remember, do you have to do that? No, it just makes things look a little bit cleaner. It might help out in the long run. If I take the 5 out, I get x, 2y, 5z would be 90, 98. Yep. You had 98. If it was 95, it would have ended in a 5. Okay? Which means I'm going to get rid of that equation again. I'm not going to look at this one. So right now I have x plus 2y plus 5z is 98. I also have x plus y plus z is 25. Just making numbers easier to work with. Last sentence. It said the number of dimes is 1 less than twice the number of nickels. Number of dimes is, which variable is dimes?
Why?
Why? What does the word is mean in math? Y is 1 less than double the number of nickels. What's the nickels?
2x.
So it'd be 2x minus 1. Very good. Okay. Kind of. What's that? It's exactly what it is. Because now you have it set up where you don't have to do the whole elimination methods for all three of them. What we can do here is we know what y is. Y is 2x minus 1. I'm going to substitute in for y in both equations, and then I'm left with two variables with with x and z. So if we do that, I'll do this over here. I'm going to get x plus 2 times 2x minus 1 plus 5z is 98. Distribute, I get 4x minus 2. So that tells me I have 5x plus 5z is 100 for that first equation. Combine like terms, move the negative 2. Do it again with the next one. The next one, if I substitute into here, we get x plus 2x minus 1 plus z is 25. Okay. So I have 3x plus z is 26. So far, so good? Correct. I have two equations, 5x, 5z, 100. What am I going to do with that one right away?
Yeah, so when you multiply the bottom by 5.
What? Can I just do this?
Oh, yeah.
Because if I do that, isn't that even quicker? Yes, sir.
Shouldn't, hold on. Yeah, shouldn't it be 24? 3x plus z is 24.
Oh, because you take the 1 and then negative 1 and add it to both sides.
Yeah, yes, but you know, it should be for the equation the number of guys one less than twice the number of nickels. Oh, I had it wrong. I just accidentally in the original equation put 2x equals y minus 1. Good conversation.
Sometimes you have to say it out loud to see what went wrong, and that's fine. Okay. Now I'm just going to subtract those two equations, eliminate z. Work with a lot of scalars here. This works fast. So if x is 3, what's z? 17. So I know right away that x is 3, z is 17,
And then y is 5.
y is 5. What's that? Nope. Because we know x is 3, 3 plus what is 20? Oh. And then 2 times 3 is 6, subtract 1 is 5. 3 plus 5 plus 17 is 25. Okay. I substituted that. X plus 2x minus 1 is 3x plus z, add the 1. Sir.
Where did the x come from? Or x equals 20 equation?
I cut this 1 by 5.
Okay.
I took the scalar out. It's just because I knew that I already had a z here, and these are all multiples of 5. It's just quicker. Instead of trying to multiply out by 5 and then subtract and do all of it, it's just a faster math.
All right.
It doesn't. You can go the other way. It doesn't matter. You'll get the same result.
Yeah, I'm just going to wait. That's just
It just comes through like that.
Oh no, I'm talking about the top. So it's the top.
Oh, okay. Yeah. Same idea. I took this value of 2x minus 1. Shh, guys. 2x minus 1, I substituted in here. So I have x plus 2 times the quantity, 2x minus 1. So I got 4x minus 2. So x and 4x is 5x. Brought the 5z over. The negative 2, I added to the 98.
Okay. Don't have
That's okay. It happens. It happens. All right. Flip over real quick and look at the top one on the other page. One of the things that happened when I was trying to piece this together, I didn't realize until after I printed it that it forgot to say, find the cost of all 3 items. Find the cost of the poinsettias, the wrapping paper, and whatever they're at, the wreaths, I believe. So there are 3 costs there. I want you to find the 3 different prices. The rolls of, like, what's the price of the garland, what's the price of the wreath, and what's the price of the poinsettias.
So would you do like 2x plus 4y plus 2z equals that?
But you can make this more complicated for it if you'd like. Again, it's just kind of crappy because you have decimals and stuff, but a lot of them you work out. I mean, you look at that first one, 2, 4, and 2, what are you going to do? You divide the whole thing by 2 right away, you get an x and a y, and I'll use that x and y value to use the one to eliminate for the other 2. You know what I mean? Make the scalars work for you.
But essentially that's what you do.
The other one that people were having issues with when we started working on this was on 24, people were getting really, really bad decimals. If you read the question on 24, the very next one talking about tickets, it says how many of each type of ticket was sold for the showing, for the movie or whatever. Can you have a .73 ticket? No. So you know that somewhere along the line you screwed something up. So let's walk through this setup again together real fast before we let you guys loose and we'll wander about here. It says that the theater has tickets that are $6 for adults, $3.50 for students, and $2.50 for kids. What are your X, Y, and Z's going to be? Yeah, go right in order. Adult, student, so X, Y, Z, adult, student, and kids. By doing it that way, you'll also be able to reference back what everything means as you're doing it. So it talked about how much everything costs, and it talked about a total number of tickets. This is very, very similar to the one we just did. How many tickets were sold?
278.
278. So the combination of all three of these has to add up to equal 278. How much money was sold?
1,300.
So we know that the combination of the money, 6x, 3.5y, plus 2.5z is 278. Oh, I'm sorry, I read the wrong number. They're right next to it. Thank you. Okay. And then lastly, it talked about the difference in one ticket versus another. It says the number of adult tickets sold was 10 less than twice the number of student tickets. 10 less than twice the student tickets. Well, adult tickets is what variable? X. Okay. What method are you going to do first?
Input it.
Yeah, if you want, go for it. If you want to multiply by 10, I don't think it matters so much in this one because once you start combining things, it works pretty decently. So, but if you want to do that, there's nothing wrong with that at all. Okay, there's nothing wrong with that at all. But I just want to make sure you guys saw how that setup works, especially with the 10 less than something double. Okay. Also, real fast, on the very last question on this sheet, there's a line through a sentence. Ignore the line. That sentence is supposed to be there. Kind of means something in there. You guys have seen this before when I've used that little tool thing, that snap tool. Sometimes the lines stay in the problem, sometimes they don't. And it just so happened that I didn't feel like reprinting it, so you'll survive. If not, I'll get over it.
Man dies.
Yeah, right? Knock yourselves out. But not literally. Notice the difference in the wording here between these and your linear programming ones. Tomorrow we'll talk again a little bit about the linear programming, and we'll also go back and talk about what to expect on the test itself. If you think about it, when you start thinking about the test, everything that we've done in Chapter 3 dealt with systems equations, inequalities, shading, constraints, maximize, minimize, linear programming, 3x3s, and then lastly is word counts. And so there's a lot, but it's all kind of the same, isn't it? No. It's pretty simple. Then you're if you're getting decimal values for like the number of tickets, it means something's going wrong.
It was smart as
Well, that's okay, because they'll start with decimals. Okay. Just keep trying. Keep going through this.
We ever see three variable linear programming problems? So we have to figure out linear programming.
With the linear programming, it's going to be your two variable setups. I don't think I've ever seen
In favor of
a three variable inequality set up? I mean, that I'm sure they exist, but how do you define what plane to shade towards when you have three-dimensional? Then you have shading volume. You know, that would be all sorts of. Yeah. It would be kind of like using your inverted cone, like cut a cone out of a cube, and then that becomes the unshaded region in three dimensions. I don't want to do that. No. I'm sure there's a class that you have to do that in. I don't know what.
No, I don't.
What do you want?
I don't.
Yeah, figure out what the price is.
Actually,
Exactly.
oh, yeah, but
So-
vegetables. No, like multiple. I'm the best one.
Actually,
Yeah, but oh, I am. Yeah.
oh, that would be. Yeah, I actually have that.
Mr. Murphy, what's your favorite food?
Depends on the day, I guess.